Hello everyone. This is the course on engineering graphics. We are going to deal with the module on projection of solids. This module is divided into 3 lectures. So this is a series of 3 lectures. This is the first lecture in this series for projection of solids. Topics we are going to cover today: types of solids and projection of solids with axis perpendicular to one reference plane and parallel to the other. Solids are three-dimensional entities. As such, minimum 2 orthographic views are required to represent the solids. Solids can be categorized into 2 classes: polyhedra. These are bounded by flat faces or flat surfaces, and solids of revolution, they are having curved surfaces and they are generated by revolving a plane figure. That's the reason why they are called as solids of revolution. Now polyhedra can be subdivided into 2 types: prisms and pyramids. Prisms will have 2 polygons as their bases, and those polygons we are treating as regular polygons because we are concerned with only regular solids only. So prisms are bounded by 2 bases and rectangular faces joining these 2 bases, whereas pyramids, they are having 1 polygon as a base and an apex. So both prisms and pyramids, they are of various types depending upon the shape of the regular polygon of the base. They can be triangular, square, pentagonal, hexagonal, and so on and so forth. So prisms, triangular, square, pentagonal, hexagonal. You can see that they are having 2 bases: bottom base, top base, and rectangular side faces joining these 2 bases. Let's see the elements of a prism: the top base and the bottom base. Then the vertical edges, these are also called as lateral edges. The axis is the imaginary line joining the center of the 2 bases. Corner or vertex, these are nothing but the intersection of 3 edges, 2 of the base and 1 of the vertical face. So at any corner you will have 3 edges connected together. Then edge of the base, polygon, and rectangular face connecting the 2 bases. This is the vertical face, this is green color one, then this here's a yellow one, then the magenta and the blue, and so on. Now how many edges it has? The polygon is having 5 edges, so it is a pentagon. It's a regular pentagon. So this is a pentagonal prism. Similarly, pyramids, different types: triangular, square, pentagonal, hexagonal, and so on. The elements of a pyramid: base, which is a regular polygon, this is a pentagonal pyramid, base. Then edge of the base, the corner here, 3 edges intersecting at a point, that is the corner or vertex. One of these edge is this slant edge and 2 of the edges are base edges. So this is the slant edge and the triangular face connecting the base edge with the apex. This is the apex. Apex is that point where all the triangular faces are intersecting. The axis is the imaginary line joining the center of the base to the apex. Then the cylinder. Let's see the elements of cylinder. It is having two bases. Both are circular, the top base and the bottom base. Now cylinder, if you see, it has been generated by revolving a rectangle about its vertical edge. So when we sweep through, you are going to get a cylinder, the solid of revolution. So its surfaces is that the surfaces are curved, that this surface is the curved surface, and there are no real edges on this curved surface, but we are going to draw the generators on this curved surface for construction purpose. So these are not shown as object lines because they are not real edges. So when we draw the cylinder, we are not going to show the generators as object lines. Generators are drawn for construction purpose and they will be shown with a projection line only. Then the axis joining the midpoint of the two bases, and then the cone, the bottom base, the axis, the generators and the apex. Now let us see the projection of solid whose axis is perpendicular to one reference plane and parallel to another. Let us take the example and understand this concept. Question 1. A square prism, edge of base 50 mm and axis height 75 mm is standing on its base on HP. Draw the projection if its edges of base are equally inclined to VP. Now what is given is that a square prism, this is important. The prism is there and the square prism is there. So it is a square prism. It is standing on its base. It is standing on its base on HP. What does this mean? It means that axis is perpendicular to HP. And when it is perpendicular to HP, it will be parallel to VP. So, and how the positions of the edges are given? If its edges, the base edges are equally inclined to VP. This is important. So all the base edges are equally inclined to the VP. Now just imagine the shape. So this is how it is. A square prism. The two bases are square, so it's a square prism. And the rectangular surfaces bounding the two bases. You can see that it is kept in such a way that all the base edges, all the four base edges are equally inclined to VP. VP is here, so they are making 45 degree with the VP. All the base edges are making an angle of 45 degree with the VP. So that is satisfying the given definition. Now let us solve this on AutoCAD. So this is the AutoCAD interface. When you open the AutoCAD, you get this interface. Now necessary changes for these solids, there are two changes which I would suggest, which you can do for all solid problems. One is that you can keep the grid on. Now you can see here the grid is on, okay, but still I am not getting any grid there, so I need to do some settings. So go to snap settings or grid settings. You see here grid style. Okay, so you can click this 2D model space, display dotted grid in 2D model space. Okay, now you can see that you can, when you switch on the grid, when you switch it on, you get the dots on the screen. These are helpful for drawing the solid projection of solid problems. during printout you can switch it off and take the printout, so it will not come in the printout. But for drawing purpose it is helpful, so you can make this one change, that is snap settings and grid settings. Another thing is that I assume that you have already created the different layers which we need for our sessions, AutoCAD sessions. All these layers, necessary layers, have been created. This is just for your reference, I am highlighting this. You know how to define the properties of these different layers, so you will do this thing uniformly for all the problems of AutoCAD. Now let us come to the sum. What we are supposed to draw? We are supposed to draw square prism, edge of base 50 mm. So for that square we will move to this polygon tool. Polygon, number of edges 4. So press enter. Now it is asking to specify the center. Instead of that, just press the down arrow key from the keyboard and select this edge and enter. Now you have to give the dimensions of the edge which are given as 50 mm. Now it is asking to indicate the first point, so let us indicate the starting point. Okay, and now ortho mode is on. Okay, so ortho mode is on, not an issue. We have to give the inclination in such a way that all the base edges are equally inclined to VP. Now with ortho mode that is not possible, so switch it off, ortho mode. Now you can see that you can turn it and put it at any position. This is what is required. How to get to that? So press tab key. So you are here in the edge dimensions, so edge 50 mm, type there 50, again tab key. Now in the angle you will type 315 and hit enter. Now you see that all the edges are making 45 degree with VP. Now VP we will represent with a XY line. Now for that we need ortho mode on for drawing the XY line. You keep some distance. So this is the XY line. Now this face which is seen in the top view, this is of object line because we are going to see it, right? Okay, so we can change it to object and you can keep this display line weight here so that you will get a proper thickness of the lines. This is the square, this is what you will see in the top view. Now let us draw the front view for this. For that we need to take the projections. Okay, now we need to locate the center of this top face also for drawing the axis. That also we can draw. Now this two intersection of these diagonals is going to give you the center of this face, top face or top base, and axis is seen as a point here only because this is the top view. Now let us complete the front view. What is the axis height? Axis height is given as 75 mm. Line. (75 mm) height. All right. Now when you are seeing it for drawing the front view, you are seeing from this direction, what you will see is this edge also vertical, which is there vertical. So that will also be visible. So let us show that also with object line. All right. So this is how we have completed the front view and the top view. Now important thing is that for all solids we should give proper name. We should have some nomenclature to indicate the corners of the base for the top base as well as for the bottom base. So let us follow some convention. We follow here usually alphabets for the bottom base and numbers for the top base. So you have to do that naming. You switch to dimension and hatch layer, okay, and then select single line text, single line important. And now when you give the names, switch off ortho and switch off object snap. These two are not required because they will interfere during the positioning of the alphabets. So we will switch them off. A, here before that the parameters, text height 8 points, okay, and angle 0, okay, enter. Now you can write this thing where the arrow is highlighted, I. So A, then click here near the next point, B, C and D, okay. And for the top base, 1, 2, 3, 4, and for the axis, O. Now here in the front view, A prime and B prime, comma, another point is also there, D prime and C prime. Similarly for the top base, 1 prime, 2 prime, comma, 4 prime and 3 prime. And axis, now what is happening, actually the object line is overlapping the axis line here. So priority is given to the object line, and that's the reason why we don't show any axis line here, because it is overlapped. Okay, so you see that while placing the names of the points, the positioning was not so accurate. You can edit that any time. Let us say, for example, first you have to come out of that command, press escape. So now you are out of that nomenclature command or text command. Now you want to change the position, select this character, move, okay, and then click anywhere on the screen and you can reposition this. Although this thing is a bit tedious, but it is important to avoid any further confusion for higher steps problems. Maybe problems involving 3 steps or 2 steps, because their intersection of these points is important. So this is how everything is placed properly. Now we'll give dimensions for this axis height aligned. it should start with the other side. Okay, and we should give the dimension of the base edge. So this is how we have completed both the views here. Let us see that solution here again. Okay, so this is how we have solved this. Now let us move to second sum. A pentagonal prism, edge of base 50 mm and axis height 150 mm is standing with its base 20 mm above HP with one of its base edge parallel to VP. Draw the projection. Now here we have to draw the solid which is the pentagonal prism, importantly. Okay, the base edge dimensions are given, axis height is known, and it's standing on its base parallel to HP, okay, 20 mm above HP. So it's okay, it's as good as lying on the HP, only we'll keep it 20 mm above XY line instead of keeping it on the XY line, that's it. So its axis is perpendicular to HP and parallel to VP, alright. How the base edge is positioned? With one of its base edge parallel to VP. The position of one of the base edge is parallel to VP. So that we have to take care while placing it. So just imagine it. So this is the 3D model for this prism. You can see that this edge is parallel to VP. VP is here. This is the arrow indicating the direction of observation for front view. So what we'll see in the top view, we'll see this pentagon, okay, and in the front view we'll see this rectangle, and the other side with this one rectangle. These two rectangles will be seen. So if you draw it on AutoCAD, we have to follow the same procedure. We will draw this pentagon using the polygon tool in the similar way as we have drawn the previous sum square. Now here number of edges will be 5 because it is a pentagon. And while positioning will take care of this angle, and once we place it, we can complete the sum in the similar way as the sum for the square prism. So this is how we'll have the solution. We can make this on AutoCAD. This is the top view. Top view we'll draw first because that is clearly visible. The shape is a pentagon with one of the base edge parallel to XY because that is a requirement, and we'll complete this even with the names of the points. Then they take the projections for the front view, then complete the front view. Take care that front view is drawn 20 mm above XY line because that is what is the requirement. It is not resting on HP but it is parallel to HP, that's the thing, okay. And then give the dimensions. So you can see that this is the edge which is visible, then this vertical edge will be visible, so object lines, then this will be visible, this will be visible, so object lines. Whereas from B2, okay, B2 is not visible, it is hidden because we are seeing from this side and drawing the front view. So B2 is not visible, it is hidden, so it has been shown with a hidden line B2. And you see the axis is here, it is seen as a point in the top view, but in the front view what is happening for that axis is getting overlapped with this object, this hidden line, and as per the convention we give priority to the hidden line over axis line, so it is shown hidden only. Now let's see this third problem. A hexagonal pyramid, edge of base 30 mm and axis height 100 mm is standing with its base on HP with the two of the base edges perpendicular to VP, draw the projection. Understand what is what. First thing, you have to take care something is on HP, something is on VP. That is important. Say when something is on HP or in the VP, you have to take that on that base, on that plane. Now here in this case, what is there is resting on its base on HP, means you have to keep it on HP. Okay, so base is on HP means axis is perpendicular to the HP. That is what we can deduce from this. So let us draw that hexagonal pyramid with its axis perpendicular to HP and parallel to VP. So what you will see in the top view you will see the hexagon. Okay, and what about the positioning of the edges of the hexagon, base edges? That is given here. Here that is given that two of the base edges perpendicular to VP. So you have to take care of this while drawing the hexagon. Two of the base edges should be perpendicular to the XY line. So just imagine the shape. Okay, this is how the solid is given. It's a hexagonal pyramid with the two of the edges perpendicular to VP. Now two of the edges, this is one of the edge and this is another edge which are perpendicular to XY. That means it is perpendicular to VP. VP is here. So this is kept properly. Now we have to draw the top view. Top view, what we will see? We will see this hexagon along with the slant edges at the center, and in the front view we are seeing it from this side. What we will see? 1, 2 triangles, okay, in the front view. So let us draw this on AutoCAD. Now AutoCAD, we are going to use the similar tool set, polygon, because we have to draw the hexagon in the top view. So number of edges 6, and we will give the edge dimension. So down arrow key from the keyboard, select this edge, specify the first point. So this is the first point, let us say, and edge dimensions 30 mm edge. Okay, so that is all right. Tab and press the 270, enter. So this is the hexagon. Now it is seen as the object line, so let us change it to object, because this is visible. Then what else? We have to show the slant edges also. They also will be visible in the top view. For that, line. Okay, I will change the layer first to object only, so it is easier now. Now line. All right, so this is the top view. Now let us draw the front view. We have taken care that two of the edges are perpendicular to XY. So this is one edge, this is another edge. These two are perpendicular to XY. We will draw the XY line now. That will do with a projection layer. We'll give some gap between the top view and the XY line, and ortho mode should be on now. Okay, ortho is on now. So this is how the XY line is drawn, and now we'll draw the generators. I will draw the construction lines for getting the points. You can see that this can be extended a bit because axis height will be taking on this. Okay, now what is the axis height? It is 100 mm. So for that you need to indicate that with a point first, mark it with a point. So you need to set the point type. For that the command is ddpt, ddp type or dd point type, define point type, enter. So you get this menu, different point styles are available. You can choose any one which is clearly visible. I have chosen this. Give the point size here, 3% is okay for me, or it is okay, even it is visible, okay. And then now when I use the point command, PO is the command for indicating a point. So just type PO, so that is a point, enter, hit enter. Now above this it is 100 mm, okay. So I can put here tab and 100 here, okay. And that is all right. So this is the point, it is not shown, okay. I will do again point. From this it is 100 mm. So tab 100, tab, not coming. So I got this point now 100 mm above this base. This I will use for apex. And now line, object layer, ortho is not required now because inclined line I would be drawing. All right. And for this vertical or for this slant edge also object line is there. All right, done. So these are the two views, the top view as well as the front view for the hexagonal pyramid, such that two of the base edges are perpendicular to VP. And now we will do the rest of the things like naming and dimensioning. So the solution is done now on AutoCAD. We have drawn both the views, the top view as well as the front view. Next problem, pentagonal pyramid, edge of base 40 mm and axis height 100 mm is standing with its base on HP with one of the base edges perpendicular to VP. Draw the projection. So here this is almost similar to the previous one. Instead of hexagonal pyramid, now it is a pentagonal pyramid, and here one of the base edge is given as perpendicular to the VP. Okay, now it's a pentagonal and one edge of the base is perpendicular to VP, whereas it is resting on its base on HP, means axis is perpendicular to HP and parallel to VP. So just imagine the solid. So this is that pentagonal pyramid. Okay, so pentagonal pyramid, so base is pentagon with one of the edges drawn on the left side here, which is perpendicular to VP. VP is here, okay, somewhere. Okay, I am not indicating with the highlighter. So this is the base edge which is perpendicular to the VP. VP is here, and this is the base edge which is perpendicular to VP. So we will draw the top view for this. When we see from the top, what we will see? We will see this pentagon and these slant edges. And what we'll see in the front view, we are seeing it from this side. For front view, we'll see one triangle and another triangle here. So just imagine the views. And these are the views drawn on AutoCAD. This is the top view. We have drawn the edge of the base perpendicular to VP, and we have kept it on the left side of the observer. It's fine. You can keep it here also, and the apex will be here then. That is also okay. And front view, this is the front view. So front view, when we see from here, we'll see this and these two triangular faces. So those two are shown here, 1 and 2. What about the axis? Yes, axis is visible here. Axis is actually not overlapped by any other type of line, and axis is from this, it is seen as a point here in the top view. In the front view, the position is here, and that is shown by a center line. Let us take this now. A pentagonal pyramid, edge of base 35 mm and axis height 70 mm, has its base in the VP with one of the base edges perpendicular to HP. Draw the projection. Read it carefully. It is a pentagonal pyramid. Okay, fine. What else is given? It is resting in VP. It has something is in there in the VP, means that it is on the VP. Okay, so it means that axis is perpendicular to VP and parallel to HP. So with one of the base edges perpendicular to HP. Now one of the base edge is perpendicular to HP. That is how it is positioned. It is resting on VP now. Okay, it is on in the VP. So what you will get in the front, we just see, imagine it, imagine the shape now. This is how, yes, okay, we are seeing it from this side. So now it is on the VP, because something is there on the VP means you have to keep it on the VP. So when you see it here from the front, now you will see that polygon here in the front view. So front view, what we will see the pentagonal plane plus the slant edges. And what you will see from the top, you see here from the top, here you will see the two triangles. Okay, so just draw these two views in AutoCAD. So these are drawn on AutoCAD now. You see now, only the thing is that now it is on the VP. So this polygon, in this case it is a pentagon, it's above XY because it is in the VP now. And one of the base edge is perpendicular to HP. So this is that base edge which we have kept on the right side relative to this origin, and this is on the this is perpendicular to the HP. So this is perpendicular to XY line. Fine. And apex is here. So this is the front view now, and we'll see from the top and draw the top view. So top view, seeing from the top, we are going to get these two triangles, one for this and another for this. Fine. So this is how the top view is completed. And let us see now a hexagonal prism, edge of base 30 mm, axis height 75 mm, has its base in the VP with the two of the base edges perpendicular to HP. Draw the projection. Okay, read it carefully. It's a hexagonal prism. Alright, it's a hexagonal prism. Dimensions are given, has its base in the VP. Again, this is having its base in the VP means axis is perpendicular to VP and parallel to HP. With the two of the base edges perpendicular to HP, the positioning of the base edge is such that both of the base edges are perpendicular to HP, and we have to draw the projection. So just imagine this, it is resting on VP now, and it's a hexagonal prism. So this is what you get, hexagonal prism. Okay, so you are seeing it here for front view. What you will see, the hexagon in the front view such a way that two of the base edges, this is the one and this is the other, these two are perpendicular to HP. So HP is here, so these two edges are perpendicular to HP. And what you get in the top, you see here from the top you get the rectangles in the top. So let us draw these views in AutoCAD. So these had been drawn in the AutoCAD. So this hexagon is seen in the front view now with two of the edges, this one and this one, perpendicular to XY. And this is the top view. Top view we are going to see here from this direction. We will get these two rectangles. So this is that rectangle for this, and for this this is that rectangle. Fine. And now let us see one more sum here. Write a circular cone, diameter of base 40 mm and axis height 75 mm, has its base in the HP. Draw the projection. Now here it is a cone and it's resting on HP on its base, so axis is perpendicular to HP, parallel to VP. That's it, it's very simple. And we have to draw the two views for this. Just imagine the cone, it's a simple thing, it's a cone resting on HP, base is circular, it's lying on HP with the axis perpendicular to with the axis perpendicular to HP and parallel to VP. And what you see from the top, you will see the circle, and what you see from the front, again a triangle, because we'll see that as a triangle. So let us draw that on AutoCAD. So we'll draw the top view. For the top view, we'll draw this circle first, and then we'll take the projections. We have to divide this circle into around minimum 8 parts for construction work only. I have divided it into 12 parts, so it is okay. More the number of parts, better the curve. For this problem, at least you don't need so many parts, but for other problems which involve 2 to 3 steps, you need to get more points for joining the points with the freehand curve. So these generators have been drawn, and the front view, we will get this front view. Now you see that the generator is not shown with object line, because this is not a real edge. These are imaginary lines drawn on the surface just for sake of construction. That is the reason why they are not real edges. As like pyramids are real edges, but here for the cone, these are imaginary lines drawn on the surface and not real edges. So no object line to indicate the generators. Only end generators are shown with object lines. So these are the two views for the cone. We will stop here for this session, and we'll continue our discussion in the second session.